Imagine you're in a bustling office, working on a crucial data analysis project. The deadline is tight, and you have to process a massive dataset to derive meaningful insights. You start with basic Python lists and loops, but soon realize it's slow and cumbersome. Your code is taking forever to run, and you're starting to panic. This is where NumPy comes to the rescue. NumPy, short for numerical Python, is a powerful library that provides support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. Python list versus NumPy array. Python lists are dynamic data structures that store items of any data type. In NumPy, the array object is called nd_array. All elements must be of the same data type. It cannot mix integers and strings in the same array. Memory efficiency. Python lists store size, reference count, object type, and object value, which increases memory overhead and slows down operations due to dynamic type checking and memory allocation for each element. Conversely, NumPy arrays are fixed size and require all elements to be of the same data type, making them more memory efficient and faster for numerical operations due to contiguous memory blocks and optimized C libraries. Performance. Python lists are slower for numerical operations, especially for large datasets. NumPy arrays provide faster performance for operations, especially for large datasets and numerical tasks. Size flexibility. Python lists are dynamic, meaning you can append, insert, or remove items easily using built-in methods. NumPy arrays or nd_arrays are fixed size upon creation, cannot dynamically change size, append, or remove elements without creating a new array. Let's explore the practical steps of using NumPy in Python. Step 1. To use the NumPy array, you must first install NumPy using the pip install command. Enter this command in your command line interface or terminal. This will download and install the latest version of NumPy available. Step 2. Once installed, you can import it using the import command, as shown here. Let's take a look at a few examples. Here, we have a simple Python list with 5 elements. As you can see, when we run the code, it will print the data type, which is list in this case as shown here. Now let's convert this list to a NumPy array by using the np.array command. When we run the code, we will see that the data type is numpy.ndArray class. Now let's create a new NumPy array. Here, we can use the same np.array command and pass it a list of items to be placed in the array. At this point, our array is flat and has only one dimension with a default data type, which is integer 64, and shape with the value of 3. We can create a 3-dimensional array and initialize its value to zeros using the np.zeros command, which specifies the array's shape. In this example, the resulting matrix is 3-dimensional. It has a depth of 3, meaning it has 3 2D matrices, and each 2D matrix has 3 rows and 3 columns. Here are a few quick lists of NumPy commands. np.array command to create a new NumPy array. np.ones command create a NumPy array and initialize its all values to 1. np.arrange create an array with a range of values. Here it will create an array start from 0 and end before 10 with spacing of 2. np.reshape reshape an array without changing its data. Here the reshape command will change array to the dimension of 3 by 2. To learn more about NumPy, you can visit the documentation at numpy.org. NumPy is not just a Python library, it's a game changer in data analysis and scientific computing. Thanks for watching. Subscribe to the channel for future videos and updates.